Hello, I'm Miguel Duarte, a senior software developer working for Red Hat on oVirt's networking team. I work mostly in SDN related topics, specifically on the integration between oVirt and oven, which stands for Open Virtual Network, an Open vSwitch project. Here you can find my email address, my IRC handle in oVirt's channel, and also a reference to my GitHub profile. The purpose of this presentation is to showcase the security group feature, which was introduced in oVirt's latest release 4.3. Let's start off by walking through the agenda of the presentation. We'll start by the motivation and goals behind security groups, and we're especially interested in the problem they solve. After that, we'll explain what security groups are, followed by the concept of port security, specifically how it relates to security groups and how it impacts the data plane. We'll also introduce and explain the relevant entity elements of the networking API, which in OpenStack is implemented by Neutron. We'll proceed to explain the concept of the default group, what it does, how it is implemented, and how it can be manipulated. I'll wrap up the presentation with the most interesting part, which is an Ansible-based demo where we'll see how security groups can be used to achieve certain scenarios. The first question we gotta answer is what's the problem security groups are trying to solve? And they solve the issue of access control. Security groups define what type of traffic is allowed to and from a virtual machine in a fine-grained fashion. It's a lot easier to explain what I mean with fine-grained fashion through examples. So let's use those. What I mean here is that you could specify the allowed traffic using a range of layer 4 ports, or you could specify which protocols are allowed. For instance, you could allow all TCP traffic, or you could allow all ICMP traffic. You could also combine these two concepts and allow a UDP port range. The access to services running on virtual machines can also be specified using the client's remote IP address or the CIDR of the network to which the client is connected. This access could also be configured at an higher abstraction level through group membership. That means that only clients belonging to a group or groups, since it allows a group list, will be granted access to target VMs or a subset of services running in them. Another objective of our implementation is to mimic the Neutron's networking API behavior as close as possible in order to match the user's expectations. The second question we need to answer is what security groups actually are, and they are a whitelist of rules akin to ACLs. This means that by default, all types of traffic is dropped, and you have to physically whitelist each and every type of traffic you are interested on, meaning that you need to provision rules to allow those flows. The second concept we need to explain is port security. Port security has two different objectives. First, it allows MAC spoofing protection by limiting the MAC addresses that can communicate through the logical port, and the second one, which is more closely related to security groups, is that it activates security groups on that port. When I say activate the security group feature, I mean that all non-whitelisted traffic will be dropped. Remember, everything is dropped by default when you have port security enabled. It's very important to mention that port security is enabled by default on oVirt 4.3. It can be updated on the provider configuration file nevertheless. To provide out-of-the-box connectivity to virtual machines, the default security group is used. When a port is created, having port security enabled, the provider assigns a default security group to that port. Again, unless otherwise specified. Port security can be applied to logical ports and to logical networks. When port security is set on a logical network, it simply means that all newly created ports whose port security attribute is not specified will inherit that value from the corresponding network instead of from the configuration file. This means that an update to port security on a logical network will not cascade down to the existing ports. Port security at port level can be updated through the REST interface or through Ansible, while at network level it can be updated through the user interface, Ansible, or REST. The relevant entities of the networking API are security groups and security group rules. The first thing we need to understand is that a security group in itself is nothing more than a container of rules, plus some metadata that is helpful to debug the data plane. Without rules, security groups provide no value whatsoever. They're just an entity element that allows a set of rules to be applied to logical ports. A security group rule specifies which type of layer 3 or layer 4 traffic can access or exit the logical port. For instance, you cannot create a security group rule specifying which MAC addresses can access a given service. It can only use layer 3 or layer 4 semantics. The security group rule is scoped to the security group and direction. By scoped, I mean that you can have the same rule in different groups. And by direction, I mean that if you want to allow all ICMP traffic to and from a VM, you will need to define one rule to allow incoming ICMP traffic and another rule to allow outgoing ICMP traffic. The parameters of the security group rules are the ether type, meaning IPv4 or IPv6, the IP protocol, TCP, UDP, or ICMP, the layer 4 port range. For instance, you could allow all incoming traffic to ports ranging from 5000 to 6000 or to a single specific one by indicating its min-max indexes to be the same number, let's say 80. You can also specify the remote IP prefix. It can be a specific IP address or an IP network CIDR. And finally, the remote group ID, which would be the ID of a security group already provisioned in your system. The goal of the default security group, as previously mentioned, is to provide out-of-the-box connectivity both to virtual machines and to the outside world. As previously stated in this presentation, whenever a port is created having active port security, it is automatically added to the default group. That is a key step to achieve the default group's goals. The user can bypass this by specifying different groups at port creation time. It is, for all effects, a simple list of groups. For instance, to isolate the port from the network, you can use an empty list of security groups. There is a unique characteristic to the default group. It cannot be deleted. Cannot be deleted. But its rules can be, and new rules can be added to it. This means that the default group can be customized to enable certain scenarios out of the box. Finally, we'll be discussing how is the default group implemented. It is implemented using 4 different rules. One rule that allows all outgoing IPv4 traffic, one rule that allows all outgoing IPv6 traffic, one rule that allows all incoming IPv4 traffic originating in virtual machines that belong to the default group, and finally, one rule that allows all incoming IPv6 traffic originating in virtual machines that belong to the default group. So, we're going to be showing the demo now, and this is the first scenario that we'll see. So in oVirt, we'll have provisioned one network that has this CIDR 172.20.50.0/24, and we'll have 3 VMs connected to it, all of them belonging to the default group. So to follow the demo, we'll need a deployment of oVirt, and I have that already available here. So let's move to our oVirt deployment. So we have our 3 virtual machines running here. Let's first show the version. As we can see, we're running oVirt 4.3 already. And here we have our 3 virtual machines. It's important to also check the network. Here we have it's called SecureNet. It has 1 subnet, with the CIDR mentioned in the DHC diagram, 172.20.50.0/24. So first, let's check our virtual machines, open a couple of consoles on the web client. Let's check its IP, move it here, and also open the web server. So we can try to ping the other virtual machine. We can see its IP right there. So we're going to ping 172.20.50.2. Okay, I was a bit scared, but okay, this is working. So as we can see that we have connectivity between them, and for instance, we can also see, we must check the IP address of the web server, but we can see, for instance, also see that the web client machine is able to curl the web server, which is on 172.20.50.4. Here we have the reply from the web server. So you might be wondering, so what does this prove? This doesn't prove anything, and that's quite sure. So what we're going to be seeing, the first thing we'll see is the state of our ports, and to do that you can use this tool I've provided, or you can also use the OpenStack CLI. So as we can see here, we can list the port information, and here we have our 3 logical ports, and as we can see that all of them are members of the security group that has this ID, D17D9641. This one features the same group membership, and the third one as well. So we can also see that we have here our default security group that has this ID, and we can see the 4 rules that make part of the default group. So we see an egress rule allowing IPv4, an ingress rule allowing IPv4 to members of the default group, another rule allowing ingress IPv6 up to the default group, and finally a rule allowing egress IPv6. So we can now, what we're going to be doing now to see that the default group actually does what I claim it does, is to remove the membership of the default group of all the ports. To do that, I've provided an Ansible playbook called Update Ports. It's on the, you can find it in this link here. You can find it on my GitHub profile. It's the oVirt Security Groups demo repository, and you can find all the playbooks used throughout the demo. So update ports.yml, and we need to indicate which security groups we want. So if we pass it an empty string in this variable, the security groups, it will clear all the security group membership of all the ports. So it's updated all of them, and we'll now move to our VMs, and we see that we can no longer curl nor ping one VM from the other. Again, we'll see what we're left to do is to see that our ports are no longer members of the default group. As you can see, it has no group membership. Now again, let's move to the VMs. Let's make a ping. It's not working. Let's update the membership now to the default group. We can see here what was the group ID of the default group. So we're now updating the ports, making them members of the default group again. And if we move to the VMs, we'll see that pinging and accessing the web server is again possible. So this demos the default security group. And with that, let's move to another scenario where we remove the membership to the default group, but we provision a new group that allows ICMP traffic. And we'll see that ICMP between the VMs is possible, but the web traffic between them is not. For that, let's check the README on the repository, and you can also see that it's neatly detailed and explained here, like the parameters to the playbooks and all that. So you can also follow the demo on your own by following the README and using the supplied playbooks. So the first thing we're going to be doing is to provision this ICMP group, because what we're trying to achieve is have these 3 VMs. First, remove the membership from the default group and attach them to the ICMP security group. So the first thing we need to do is to provision this new group. For that, we need a terminal, and let's provision the ICMP group. I'll show you briefly the contents of the playbook. As you see, it leverages the OS OpenStack security group module, and it provisions a group, registers the result of this group, and then provisions a rule in this using the ID that we previously registered before in the group. So now we have the group created. Let's check our groups, not the ports. Let's check our groups, and we'll see that we now have a different group that has 3 rules provisioned. As we've seen in the playbook only created 1 rule. So how come we have more rules here? So the thing about mimicking the OpenStack's implementation on Neutron is that whenever you create a new group, it gets automatically provisioned with 2 groups that allow all egress IPv6 traffic and all egress IPv4 traffic. So here we have our rule that allows all ingress ICMP traffic. So we have provisioned the group. What we need to do now is to update the ports to be members of this new group. For that, we need the group ID, which is here, and we'll update the ports, all of them, to be members of this new group ID. So the playbook succeeded. Let's move to our VMs, and you'll see that curl is not possible. We cannot access the web server, but that we indeed can ping the virtual machines. So this scenario was successfully achieved. Let's move to the next one, where we want to do the exact opposite. We want to allow web traffic from the web client to the web server, but we want to block ICMP traffic. I'm only using the web client VM, but from the other one, the Nisu VM, it would reach the exact same behavior. So let's move again to the console. Again, you can follow the README to achieve this, and there's a playbook provided that provisions this web-based security group. So we create the web-based group. Okay, this was not meant to happen. Okay, it's because the group already exists. So let's showcase that we can also delete the group using the same playbook. This is an interesting thing. This was unexpected, but you can also use the playbook to remove the groups that you're creating. So let's create the group again. Okay, as we can see, it created a security group meant for web servers. This part that is skipped will be used in another scenario later on, and that it provisioned the rule opening up port 80. I'm going to show you the playbook. So we create a security group meant for web servers. We register the result in a variable. This part was skipped on this scenario, and we provision a rule on that group, on the security group, using the variable that we registered here. And this remote group part for now is omitted because we did not feed it the web client rules holder. We did not create the web client group. So let's again check that we got this new security group and get its ID so that we can update all the ports in the system. So let's look for the server. Here we have our web server group. Again, it has 3 rules, 2 of them automatically created, the egress ones that allow IPv6 and IPv4 traffic, and that there's the rule we created that allows TCP IPv4 to ingress to port 80. We could have used this port range min and port range max to open a range of ports, but we are only opening up port 80, which is where our web server is listening. So what we have to do now, let's move to our VMs so we can still ping, of course, because they are still members of the ICMP group. So let's move back to the terminal, and let's first get the ID of the web server. Here it is. So you can get the ID of the security group by getting the reference of the security group ID that are on the rules, for instance. So what we're going to do now is again to update ports and pass it the ID of this new group. The playbook succeeded, and if we move to our VMs, we see that pinging stopped. So it's no longer allowed. ICMP traffic is no longer allowed. So for the demo to be successful, we can see that accessing the web server is possible. So this scenario was also achieved.